Hi everyone, my name is Jason Myers and welcome to week 2 or 3 or whatever of IA 244. Some of you may realize the somewhat significance of the color of my shirt because the Lions are playing later on today because I'm recording this Saturday and it is January 18th. So technically this is for the week that starts the January 19th or 20th. But I'm hoping that by the time you get around to viewing this, the Lions will be on their way to their conference championships. So Honolulu Blue is here to basically show support for our Detroit Leos. We definitely do not want a repeat of the 1997 playoff game in which the Philadelphia Eagles destroyed us in the first quarter. I recall watching that game live, and Scott Mitchell must have thrown at least 3 or 4 interceptions in the first half alone. It was over by the first half. Anyways, the other significance of this color blue is that there was a certain company that was nicknamed the Big Blue. And I don't know if you know what the name of that company is, and the name of that company is International Business Machines, or IBM. Now, the reason why IBM was called the Big Blue was because they required all of their male employees to wear blue suits and white shirt and blue tie. And for the women that worked there, they also had to wear blue business attire, like a skirt or blue dresses or whatever. Similar. So the whole point is, when it comes to a cultural, I'm going to say, viewpoint, computers or access to technology was really for a certain level of persons. Like you had to have a white collar job. And that's what really technology was. If you were working for a company, it was considered like a white collar learned job. The credentials, or I'm going to say skill set, that's probably the best term. The skill set of computer enthusiasts or subject matter experts or SMEs, the task set usually came from the realm of statisticians, mathematicians, philosophers, because they knew about the logic and the syllogisms. If you ever taken a logic course, and this is the area of expertise that computer science drew from. So some of the first computer scientists, like the world's first geek squad, was people like Homer and the people that wrote the Odyssey and things like that, those ancient philosophers, if you will. Nowadays, everyone with an iPhone or an Android has the power of a large computer room. In the 60s, they have more power than the largest of large computer rooms in the 60s. They have more power than that in their back pocket. And there's like 4-year-olds that are running around, walking around with iPhones. Okay, so their parents feel guilty because both parents are working, so they give their kids iPhones, iPads, and it's just not for the rich of the rich. Middle class, low class, lower class, I should say, or working class, middle class, working class, low class, people on the fringe, people in jeopardy. Everyone and their brother has access to the internet and has access to things like Kali. And on Kali, there's 3,000 pre-programmed tools for exploitation. The point is, you as a systems administrator have to realize that the other thing that this blue shirt symbolizes is that on one hand, it comes from the Big Blue, meaning IBM, but now in 2025, the sky is the limit. That's the other thing that the blue shirt that I'm wearing also symbolizes. So anyone out there that has access to an iPhone, Android, or anything that can reach the internet has the same programming power or greater than the original launching that allowed us to travel to and land on the moon. So on one hand, the sky's the limit, as his blue shirt indicates, and that should be something that is wonderful, and it should give everyone pause to celebrate. But on the other hand, as I said in a prior lecture, some would say that technology is a gift of fire because it could be very dangerous. If the sky's the limit for a 12-year-old or a 14-year-old in his or her basement, that means our job as a systems administrator is that much more challenging. So what I would like everyone to do now is to get out their PowerPoint, take a look at it, and we're going to go through the PowerPoint slide by slide. Well, the last video snippet didn't age well, I have to admit, but I have two things to say. First off, let this be a lesson for everyone. You, me, and every other Detroit fan, if you listen to sports talk radio, we're thinking that we were literally 4 quarters away from our very first NFC championship hosted in Ford Field. I mean, 15-1 season, what we did to Dallas, what we did to Jacksonville. I mean, it was stuff of legend. But the main thing is this is something to show you, or this is an example of why you should never, ever be tempted to bet on any sports team at all, or any team in the NFL, any team in the NBA or MLB. Let this be a lesson that you should never, ever bet on any sports of any kind. Because honestly, as this game shows, you never know. Myself, my betting days when I did go back to the late 90s and maybe early 2000s, and your instructor, this guy, learned the hard way: never ever bet on sports. Never. And none of this, even bet what you can afford. Don't do it at all. Just watch it for fun. The bright side is, yes, 15-1 is flushed down the toilet, essentially wasted, but we can't deny all the awesome memories that we may have had watching our winning team this season with our friends, with our family. I had a great old time watching the Lions from the comfort of my own home last night with some dear friends. We had great food, we had great laughs, and communicating with people on text. It was just a great fun, and I wouldn't have wanted to even make it even worse if I would have lost money, which I did not. I know enough never to bet on sports. And some people have said, hey, why don't you take your knowledge and you, and my other friend who actually has even way more knowledge than I do in sports, why doesn't he make money in sports? And I always tell him, because you can never ever account for all of the possible variables that come to play: the surface area that you're playing on, the referees, how loose or how strict they are, they're gonna make the calls, and if you never know if the referees have placed bets themselves. So the only people that actually know anything about sports is the people that run the bettors in the first place, the houses, because they win either way. The way the lines move, they always win no matter what. So the point is, never bet, and last night is a great example of that. Now, the other aspect that I wanted to say is, although we've talked about making connections and all that, some of you might be a bit misty on what exactly a system admin does from day to day, if you will. Well, let's take a quick tour of the daily life of what a system admin does. And of course, I'm on that first slide where it shows the smokestacks and all that. Remember, as I said, I can't mention enough that we live in a world that is pretty much all connected 24/7, and I spent last week showing you, mapping it out even, how at the end of the day we're all connected. And trust me, in this all connected 24/7 connected world, the goal of a system admin is ensuring the right people get to the right info and the wrong people are properly isolated. And when I say the word properly, I mean that they are separated by policy, and possibly, hopefully, the actual physically separated, and as in the actual network signal. Let's move on to slide 2. So what exactly does this mean? How can system admins, which seems like it requires a severe knowledge, a severe amount of knowledge. How could it possibly be a great starting point? And, how do you know everything? How does this make sense? Well, what does it all mean? It means that no one can know everything. In our current enterprise environment, there are what they call silos, meaning redundant stacks. There's Red Hat, Solaris, and AIX, which is Unix over mainframe, and now Windows Server stacks. Not only will you need to be aware of each, but having a broad brushstrokes of the differences and challenges between them and all of the political power structures and struggles. That is the key. Knowing that there is Unix, that there is Linux, that there is Windows Server out there, and knowing the differences in between is your key of awareness of these different diverse technologies. So if you walk into any computer support staff, like in Stellantis' NOC, which is North American Operations Center, or any help desk center, all the so-called eggheads or experts actually spend their day Googling, because even if you're an expert, say, in Linux, you still have to support the Unix and Windows technology stacks. And not only that, you have to support the different programming languages and also the different modalities and the different processor types, or the fact is whether or not an application is served on a bare metal computer, or is it being served virtually, or is it an actual Docker container that's being administered on some Red Hat orchestra. So these are all things that you have to take in, and you have to understand no one person can know every single silo and stack and every single different modality. No one person will know it all. And yes, you will see all those subject matter experts that are in these different desktop environments, or these help desk or network operations centers. You will see them routinely Googling things that they don't know, because there's no one person that can know everything without researching it first. It's about the confidence, really, about knowing that you can research it or Google it or look at it on Copilot or something, and you can make informed decisions that benefit the company. As we said, taking a look at slide 4 right here under roles and responsibilities, diversity is the key. So some of the sectors, or I'm going to say, skill sets you'll have to be well aware of and decent at, or at least have access to the knowledge of, in case you don't know exactly, things like networking, web admin, security, databases, and of course system administrator. So actually, when I say network, that should be network administrator, web administrator, security administrator, database administrator, and overall systems administrator. So you will have to actually have people answer to you, or you as a system administrator may have to answer to the network SMEs, but you will, as a systems administrator, be responsible for network, web, security, and databases. So for example, in terms of networking, you'll have to have basic networking knowledge. You'll have to know things like there are 3 classes of IP addresses, and here is what I'm talking about. All right, speaking of networking system administrator or network administrator, one branch of a system administrator's task set, you'll have to be aware of things like IP address classes or IP classes. So we have Class A, and that would represent the first octet, actually being 1 through 126. The 127 is a loopback. So a lot of times you hear about people that are like, okay, Usually it'll go from 1 to 126 and then skip to 128, and people are left with asking, well, what happened to 127? Well, that's because 127 isn't a class by itself, because it is what they call a loopback. That being said, Class A, in my opinion, should stretch to 1 to 126, leaving 127 as a separate loopback class. Class B is 128 to 191. Class C is 192 to 223. And Class D is 224, the first octet starts with 224. Examples of Class D multicast is OSPF, whereas RIP and RIP-v2 send a broadcast, they broadcast their networks to their neighbors, and OSPF and other routing protocols send multicasts. So we know this because a typical OSPF area signal, it starts with 22.4. It might be 224.1.1.1 or something like that, and that'll send a multicast to its neighbors instead of a broadcast. Now we have the private IP spaces, the 10 dot whatever. So you know if something starts with 10 dot whatever, it will be a private IP addresses, private IP address, excuse me. Now, a lot of times Cisco textbooks will always have addresses that start with 10, and that is because they are, on one hand, the private IP address space is routable, but yet it's private. So you can represent a IP address or topology with different routers, and each router could be its own domain. And to connect the routers together, you could have 4 or 5 routers connected together in almost like a web type connection, and maybe a bunch of serial connections or something, and you can separate them by subnet mask, and so that they're routable. But the point is, they're in the private IP address space because they don't want to by accident talk about a public, an IP address that's in the public IP space, because they could be doing some, advertising for some company without realizing it, or they could be, infringing on someone else's IP. I know if you're a public on the public sphere, if you will, if you have a public website, I certainly wouldn't want my IP address to be inadvertently mentioned in a textbook, in a college textbook. So Cisco textbooks, for example, will always use the 10 dot IP address space, because it's both, you can demonstrate routing with it because it is a routable IP address space, but yet it is private, so you will not infringe on other people's rights, because there's no way you can actually get a private IP address to be associated or to resolve to a DNS service that is public. So, in other words, you can't reserve a public IP address and have that match to a private IP address, and so that, well, you could, in theory, but you couldn't have that, in respect to a public, in a public environment, because it's private. And then we have, regardless of whether or not an address is public or private, so long as it's routable, it will have a subnet mask associated with it, whether it's a default subnet mask or a network subnet mask. So here is yet another example. So as I said, we're going to take a look at this singular example. We have a /27. So we're starting off with our IP address of 192.168.4.34. So we know based on the graph that we saw, or the table that we saw, it's the first octet is 192. So we know that's a class C. So the default subnet mask is going to be a /24, because, and let me just finish writing the /24, because the subnet mask is going to be 255.255.255 .0. That's the default Class C subnet mask. So 255 equals 81. So it's going to be /24. But this is a /27. So we move over the decimal point by 3 places. So we add 3 ones. So 24 plus 3 is your /27. So that means our networks are divvied up into 128, 64, 32, 16, 8. Those are our magic numbers, if you will. And if you are patient with me, I will go ahead. I should have written that down too. So our magic numbers are 128, 64, 32, 16, 8, 4, 2, 1. So as we progress, as we move, oh my gosh, I'm sorry. I'm just trying to click anywhere, so it just eliminates all those different squares. Let me go back to the drawing capsule right here, the drawing tools. So we go 1, 2, 3. So wherever we stop is what we call our magic number. So that represents how our IP, basically our IP networks are separated, or how our IP blocks are built. So now our networks are 0, 32, 64, and so on and so forth. 64. So you're just adding 32 to 64. That's going to be 96. So that's enough to get us started. So the way this works is there's actually 3 networks built in here. We have 2 routers. One is east, the other one is west, and there's a network that is connected on this side of the east. There's another network, and when I say another network, we're going to have printers, we're going to have laptops, we're going to have fax machines, we're going to have access points, we're going to have all the wireless connectivity that goes on and everything, and possible local data centers. So we're going to have all these kinds of resources that are directly connected to this side of the router and this side of the router. So you have to understand that if you actually divvied out the networks, the router actually brings in together every single interface that connects to it, and the same is here. So the way these broad-based connections are, we have a network here, so it's 1, and we have a network in between, so that's 2, and we have a third network on this side. So this could be your first network, so we'll say network 1. That could be your second network, and this could be your third network. So an example of a network on this side of the router, we'll call it network A. And let me grab another color right here just for separation. So we have network A, and we have network B, and we have network C. So this could be your A network. So an example of a PC or any node in network A could be 192.168.4 anywhere between .1 and .30, because you can't have 31, because that is the broadcast address of this first network, and you can't have .0 because that's the network address of this network. Consequently, you can't have 33. So if I said 33, or you can't have 63. My bad, 63. So I'll just put a red slash to that, because that's of course the network address for that. Okay, so and you can have a network, this second network, we'll call this in network B, that could be 33 all the way up to and including 62. So you just could not have 63. Okay, and similarly, this .64, you could not have .95 as that address. So in network C, which we're tracing it back to network 3, you could start with .65 and go all the way to including .94, but just not .95, because that would be network 3's broadcast address. You just can't do that. And the reason why is that if in network 2, if you were within this network 2, and let's say your IP address was 192.168.4.40, which is perfectly fine. If you went ahead and you pinged .63, that would mean everybody in this connected network would receive that request. So anyways, this is a broad-based example of what a network administrator has to go through. And unfortunately, you as a systems administrator, you may not have hands-on experience. You may not be the one to actually set this up, but you will have to be aware of how your subnets are, because you'll have to answer to why the network was improperly connected if something doesn't work out.